The day we touched the sun. On December 25th, 2021, while much of Earth was celebrating holidays, something extraordinary was happening far beyond our atmosphere. A spacecraft the size of a small car was racing through space at nearly 700,000 kilometers per hour. Its destination was something no human-made object had ever truly touched before: the sun. This spacecraft was called the Parker Solar Probe. Unlike planets or moons, the sun doesn't have a solid surface. It's a massive sphere of plasma, superheated gas where atoms are ripped apart into charged particles. Scientists had studied it for centuries, but many mysteries remained. Why is the sun's outer atmosphere, called the corona, millions of degrees hotter than its surface? How does solar wind accelerate to such extreme speeds? To answer these questions, NASA launched the probe in 2018. But getting close to the sun isn't just difficult, it's dangerous in ways that seem almost impossible to survive. Flying into fire. Temperatures near the sun can reach over 1,300 degrees Celsius, 2,400 degrees Fahrenheit, where the spacecraft travels. But the real danger isn't just heat, it's radiation and energy. The sun constantly emits streams of particles that can destroy electronics in seconds. To survive, the Parker Solar Probe carries a heat shield made of carbon composite, about 11.5 centimeters thick. This shield reflects most of the sun's energy and keeps the instruments behind it at roughly room temperature. Still, the spacecraft must follow a carefully planned path. It doesn't just fly straight to the sun. That would require too much energy. Instead, it uses gravity assist from Venus, repeatedly flying close to the planet to slow down and tighten its orbit around the sun. Each pass brings it closer and closer. Crossing the invisible boundary. For years, scientists debated whether it would even be possible to say when a spacecraft had touched the sun. After all, there's no solid surface. But there is a boundary. It's called the Alphen surface, a region where the sun's magnetic field dominates the motion of particles. Outside this boundary, solar wind flows freely into space. Inside it, the particles are still strongly connected to the sun itself. On that December day in 2021, Parker's Solar Probe crossed that boundary. For the first time in history, humanity had entered the sun's atmosphere. What it found. The data surprised scientists. Inside the corona, the probe detected sudden reversals in the direction of the magnetic field, like the solar wind was folding back on itself. These are called switchbacks, and they may help explain how energy moves through the sun's atmosphere. It also flew through structures called coronal streamers, giant loops of plasma that extend millions of kilometers into space. These regions are chaotic, filled with turbulence and energy bursts. The sun, it turns out, is not a calm, glowing sphere. It's violent, dynamic, alive with motion. Why it matters. You might wonder, why does this matter to us here on Earth? Because the sun controls more than just light and warmth. Solar storms, massive eruptions of energy and particles, can disrupt satellites, GPS systems, power grids, and even communications on Earth. In extreme cases, they could cause widespread technological failures. By understanding how the sun works, scientists can better predict these events and protect our planet. A human story. Even though no human was on board, the Parker Solar Probe is still a human story. Thousands of engineers, scientists, and researchers spent years designing, building, and testing it. They had to imagine conditions no one had ever experienced and create technology that could survive them. The probe itself carries a small tribute, a memory card with the names of over 1 million people who signed up to fly with the mission. In a way, part of humanity is out there, circling the sun. Still going. The story isn't over. Parker's Solar Probe continues its journey, getting closer with each orbit. By the end of its mission, it will come within about 6 million kilometers of the sun's surface, closer than any spacecraft ever before. At that distance, it will move faster than any human-made object in history, and it will keep sending data back to Earth, helping us understand the star that makes life possible. The bigger picture. For most of human history, the sun was something distant, untouchable, almost mythical. Now we've reached into its atmosphere, not with our hands, but with our curiosity. And that's what makes this story powerful. It's not just about a spacecraft. It's about a species that looked at a star, something that could destroy it in an instant, and said, "We want to understand you."